So we're going to look at two examples of definite integrals that we didn't have time to get to in class today. The first one is the integral from the cube root of negative 3 to the cube root of 3 of x squared over 9 plus x to the 6th dx. X to the 6th is just x to the 3rd squared, and this is basically in the correct form for arctangent. I need to go do a u substitution. I need to say that u equals x to the 3rd, and its derivative is 3x squared dx. To make that work, I'm going to stick a 3 inside my integral and a 1/3 outside my integral, and I need to change my limits of integration as well. X equals the cube root of negative 3 becomes u equals, the cube root of negative 3 cubed, which is just negative 3. X equals the cube root of 3 becomes u equals the cube root of 3 cubed, which is 3. And the problem is now 1/3 times the integral from negative 3 to 3 of du over 9 plus u squared. Go and integrate. This gives us 1/3 times 1 over a, so another 1/3 arctan of u over 3, which I'll evaluate from negative 3 up to 3. I think I'm just going to move my 1/9 out front before the brackets. 1/9 times the arctangent of u over 3 from negative 3 to 3. I'm going to go and I'm going to plug in my 3 minus, I'm going to plug in my negative 3. I've got the arctangent of 3/3 minus the arctangent of negative 3 over 3. I'm going to get 1/9 times, that's just the arctangent of 1 minus the arctangent of negative 1. Arctangent of 1, what angle has a tangent of 1? Where are the sine and cosine the same? Pi over 4. And what's the arctangent of negative 1? Remember, we're looking in quadrants 1 and negative 1. Actually, here we should be looking in quadrant negative 1. We're going to get negative pi over 4. Well, that's 1/9 times 2 pi over 4. You can cancel out the 2's there, and you're going to get pi over 18. That definite integral, the signed area under that function, is pi over 18. The other one that we need to take a look at is the integral from negative 2 to 2 of dx over the square root of 28 minus 12x minus x squared dx. And hopefully you would look at this and realize we need to do some completing the square. We're going to take care of that before we do any sort of u substitution work. This is the integral from negative 2 to 2. Whoops, I've got too many dx's there. Sorry about that. This is going to be the integral from negative 2 to 2 of dx over the square root. I'm going to take out a negative 1 from those two pieces, and I'm going to keep that separated from the 28, and I'm going to say negative x squared plus 12x inside the parentheses, and outside I've got a plus 28. We're going to do our completing the square. Half of 12 is 6. Squared is 36, so I'm going to add a 36 there and balance it up by doing another plus 36, because this 36 is actually a negative 36. I've actually changed the denominator by negative 36, so I'm going to get that. This becomes the integral from negative 2 to 2 of dx over the square root. Okay, so add those things together, you get 64. Factor that piece, you get x plus 6 in parentheses squared. Now do your u substitution. U is going to equal x plus 6. Du is dx. So I've got the integral of du over the square root of 64 minus u squared. I also need to change the limits of integration. X equals negative 2 becomes u equals negative 2 plus 6, or 4. X equals 2 becomes u equals 2 plus 6, or 8. So I'm going to integrate from 4 to 8. Go and evaluate the integral at this point. We have the arc sine of u over 8 from 4 up to 8. Plug in 8 minus plug in 4. You're going to get the arc sine of 1 minus the arc sine of a half. And now you evaluate. Where's the sine 1? At pi over 2. Where's the sine a half? At pi over 6. So this is going to become 3 pi over 6 minus 1 pi over 6, 2 pi over 6, or pi over 3. The signed area under that function is pi over 3.